Okay. So the discrete probability is something that's something that's integer cannot be separate, divided. Okay. And continuous probability is something that can be divided to so many decimal points. So it's a continuous number, and usually means like what we see can take infinite value, like time, distance, weight. This weight, could be also in decimal. That's very accurate. Yeah. So it's very similar to discrete probability distribution. The random number for the continuous probability distribution also denoted by x, the probability of x, because it's a continuous. So the x usually it will be between certain number. It won't be like last time we say for every 30 minutes, 4 customers come in. So we have the integer number 4. But in this case, if we say someone making $10,000 per month, so it might not be necessarily 10,000. We could say someone like making less than $10,000 because it's a continuous number, but it's still the total number of the possible outcome still add up to 1. Okay. So for continuous distribution, we want to see usually certain range, like I mentioned, x less equal to 2.4, x less equal to 10,000, okay, and or greater than something. So so that's how we calculate the possibility. So we have normal distribution. Normal distribution is the most common one. We see it everywhere. Like if you remember your statistic, the normal distribution is like this. Didn't work. Oh, that did. Let's try. So, try this one. Oh, it's only blue. Then change it to. Oh. Oh, yeah, so this is the normal distribution, bell shape, okay? And then exponential for the exponential is for the example that they have a lot of possibility with smaller number. So when we draw, it will look like a lot of frequency in a smaller number. Okay. Yeah. And uniform is so something like this, like it's the same probability within certain range. Okay, we'll explain that later. The examples. Okay, so the most of the example we have, usually we use the normal distribution. Did I record? I think so, yeah. And so for that, so that means most of the example happen in the center. And then there are some extremes on two sides. Okay, so this usually doesn't touch the x. This is x of y, x of, yeah, doesn't touch it. So it's just like this, okay? So that any possibility is here. So that's the normal distribution and it's bell shaped, okay? This is the most common one we use in statistics. And exponential, like I mentioned, usually it's when we have low value, a lot of low value data, the frequency happen, the low value is high, and then the high value is low. So that's the exponential, okay? That's an opposite of the, what do we have for the lambda last week? What's the second one from last week? Poisson. So it's the opposite of Poisson, yeah. And then uniform usually means, you know, the possibility this happen between these are here, are the same. There, okay, that's a possibility that happen. So like dice, when we do dice, okay. No, dice is a bad example because dice is discrete. But you know, this is like, yeah, so think of some other example. So normal distribution, bell-shaped, symmetric, okay. The usually mean and median are same or similar. So when they close to the mean, there's more possibility this will happen. Like this is mean, right? So the mean has the highest possibility this will happen. So majority of stuff happen around the mean, okay? So this area, under the curve, this area, the whole area, when we add it up, it's equal to 100%. So that's 1. So that's the possibility of the whole thing happen. The continuous, this is the continuous example. Okay, like from let's say 1 to 100. Okay, I'm just making up some numbers. It could be 10,000 or whatever. Okay, so that when you add up the whole area, it's equal to 1. So the standard deviation, it actually make the shape look different. Okay, so if the standard deviation is larger, do you guys remember how we calculate standard deviation? It's the distance, each number from the mean. So it means that if the standard deviation is larger, the data is more dispersed. So like here, the standard deviation is 2. It's the bell shape is more flat. Yeah.
It's dependent on the confidence level,
Not the shape.
not the shape, but the distance between each letter. 5%, you have to have like 16.7% on each end, some of it.
Yeah, but it's 95% always have the same z-score, right? The z, we'll calculate it, but that's not really related to this. Yeah, that's not really. So the standard deviation make the shape different. So like the standard deviation is bigger, so it's more dispersed, it's more flat. But if the standard deviation is smaller, then it's like steeper. Okay, so if as a business, if you want to look at your service quality, what do you want? You want it to be flat or you want it to be steep? Which one do you think represent better quality?
Steve.
Steep, okay? So that means there's fewer error, okay? So if this is like very flat, like this, that means I'm not a good drawer, but like if it's very flat, that means you could make something, let's say make it's a pizza, okay? If you need to make a 16-inch pizza, it might range from 12 to 20. That's not good quality, right? Okay, but if it's like even steeper than this, I can draw. But if it's like this, that means 99% of the data is within this range, very small. So that's good, but it's very difficult. So that's a standard deviation. But because we when we calculate, when we do this, so like this, we only change it's the same standard deviation, but the average is different. One is 12, one is 21. Okay, so the shape doesn't change. So the mean decide the location, and then the standard deviation decide the shape of the curve for normal distribution. Okay. So how do we know? How do we know that, like how do we identify how many percent is this area? How many percent is that area? If it's different shape. So we need to standardize the bear shape. Okay. So how we standardize is we use the mean. We use the mean divided by the standard deviation. So instead of like here, we have different means. Like let's say maybe this represent ages. Okay, then the standard deviation is 2. But instead of using this, we say everything will be based on how many standard deviation. So that means that's how we calculate the Z. So how far is our numbers from the mean? So everything will be like we will assume the mean is 0. Mean is 0. There's no difference between the mean with the standard deviation, right? So it's 0. And then it will be calculated by how many standard deviation. So if the Z score is positive, that means the value we are interested in is on the right hand side. Okay, because we want to see. So if we go back to the formula, it's x minus mu. Okay, and then let's go back here. So if x is 15 minus 12, 3 is positive. Divided by 2 is 1.5. Okay, so it's here. But if it's negative, if it's 9 minus 12 is negative 3. Negative 3 divided by 2 is negative 1.5. So it will be here, it will be negative. So if we convert it to Z score, it will be negative on the left side. Okay. But if it's 0, that means it's the same as the mean. Okay, does it make sense? So we just want to convert it to Z score so that we can know how many percent is underneath the bear shape. Okay. So for Z score, it's the same as normal distribution, but we convert it to mean equal to 0, and the standard deviation is 1. So everything is calculated as how many standard deviation. Okay, so when we use the Z score, we can change all the random number to a standard normal distribution. And then we can use the normal standard distribution table to see what's the value. And then we can calculate the possibility. Okay. So let's say example. The possibility that P is less equal to 14 when the mean is 12, the deviation is 3. So if I draw it, so if I draw just a normal, like the distribution based on this example, it could be. So this is the mean, mu, this is 12. And then the standard deviation is equal to 3. And we want to know the possibility of this is 14. So anything here less equal than 14. What's the possibility? What is this area? We want to know that. Okay, so we should convert this to Z. The same chart. So this will be 0. When we convert this to Z, it will be equal to 0.67. So it'll be here, 0.67. So it's the same, exact same area. But now, when we convert it to Z, we can go look at the Z table. Okay, so when we look at Z table, Z equal to 0.67, we can see it's 0.7486. So we can find it. Should be. Yeah, so this is how we look at Z table. It's 0.67, right? So we look at 0.0 and then 0.6, 0.6, and then 67 is. So the possibility of that would be 0.7486. 86% of chance the P is less equal than 14 when the average is 12, the standard deviation is 3. Okay. And then this go back to what you asked. So so plus minus 1 standard deviation is usually 68% of the possibility. Okay. Oops. Good. So let's do this. So let's say this is 0, and this is 1 standard deviation. So this area will have 68% of it's 68% of the whole area. Okay, and then if we convert it to, if we go to 2 standard deviation, add one more. So the green area be 95% of the whole area. And then 3 standard deviation. So add one more standard deviation here. So 3 standard deviation. So the ray area, the whole ray area would be 99.7% of the whole area. Okay. So that's why, in the operations management, in quality management, we talk about 6 sigma. Okay, 6 sigma. Then we can minimize the whatever is not within the standard so much more. Okay, so in theory, so like here, this is 3 sigma. In 100 product we make, 99.7 will be within the acceptable range. Okay, only 0.3 out of 100 will be defect. But if we change it, if we say our standard is 6 sigma, then 6 sigma, there will be only three defect in 1 million product. Okay, so that's why, you know, the business started to talk about 6 sigma. So this is the normal distribution. So let's use one example. So based on a survey, it shows that snowfalls in Minneapolis fits normal distribution. The average of the survey data is 45.7 inches when they have snowfall. Standard deviation is 18.1 inches. What's the possibility that between 30 and 70 inches, they have the snowfall between 30 and 70 inches? How about the possibility that it's between 60 and 75 inches? So again, let me draw this so it will be easier to understand. So there are 2 questions. So the first one, the average is 45.7. Okay, so the first question is between 30 and 70. So 30 and 70. Yeah. So first we want to figure out the possibility in this range, 30 and 70. Okay, and based on our table, remember our table shows the whole area, right? So based on that, we need to do the 70. So when we calculate the z-score for 70%, we get this area, the whole area. So we need to use the P70 minus P30 is here. Okay, so then we get area in between. Then we get the area in between. Okay, so it depends on what kind of table we have. So we have to see what kind of table. But based on the previous example, our table is like, you know, the table shows the whole thing, like the 0.000 will be by 50%. So everything, this half, and then they just keep adding. Okay, so in that case, we have to use this minus the 30. So that's the first one. The second one is between 60 and 75. So the second one is still the mean is 45.7, and then 60 and 75. So the second one is between these 2. Okay, again, we use the area here minus the area here to get this area. I hope it's reported. Does it make sense? So we have used the Excel norm dot, it should be norm dot this, and then the standard deviation, the X, and then the mean standard deviation, cumulative or not. Okay, so in this case, we need to do cumulative. So we get the whole area first minus the second. Let me do it. So. So let me just, is it 45.7? And the standard deviation is 18.1. 18.1, and then we want it to be 30 to 70. And then the second one is 60 to 75.
Yeah.
60 to 75. So let's do here the normal distribution here. So the first number is probability. This is the X. So this, let's do this one. And then the mean. And then standard deviation. And then, is this right? Oh, no, I select, sorry. I used the wrong one. Should be normal distribution. Click the individual. Now, so it should be X. Then mean. And then standard deviation. And then 2. So this is the 71 minus the 31. So 30, and then average, and then standard deviation, and ta-da! So 71% of chance. This will be between 30 and, or we can do, not do this. So this shows us the numbers. Okay, and then use this minus this. And then I can do show you guys. So A1, A2, do other sign. Let's find. We see if it works. So we can do this. We can copy the whole thing. So let's double click. Yeah. So this one is the 75%, right? So this is 75%. And then the next one is 60%. And then this is standard deviation, normal distribution, and then minus, yeah. So between 60, 75 inches, there's only 16% of chance. It will be between 60 and 75 inches. Okay, and this 71.74% of chance, the snowfall will be between 30 and 70 inches. Any questions? So just use norm, this. Change this. Start. Okay. And then last time we talked about binomial distribution, and remember the formula is very annoying, right? So the statistician found out if the sample size n is big enough, so the n, when the n times p and the n times q is greater than 5, then we can pretty much use the normal distribution to replace the binomial distribution, okay? But when the sample size is huge. So the next one, exponential distribution. So like I said, this is opposite of not complementary to the Hassan. Hassan is within how many, like certain period of time, how many customers are coming, how many product can be made. This is the opposite, means that how long it would take for one customer, like between two customers, how long it would take for another customer coming, okay? Or for another product or another machine is doing. So the formula is like this: lambda times E is the constant number 2.718 to the power of negative lambda times X. So I still don't know what it is, but you know, it looks very similar to the sum, but like I say, opposite. So for exponential probability, we use 1 minus E to the power of sigma times negative to the power of negative sigma times lambda. Okay. And the average is 1 over lambda. Hassan is the average is just lambda. And then the standard deviation is 1 over lambda to a square root of 1 over lambda. So the average time to have a customer is 4 minutes. So that means the nu is equal to 4. And then the lambda in this case will be a quarter, right? Because nu is equal to 1 over lambda. So the lambda is 1/4. So let's say the average time to have a customer is 4 minutes. What's the possibility that the next customer will arrive between 4 and 8 minutes from now? So we use Px8 minus Px4. Okay. So this. So the formula is this: 1 minus E to the power of sigma lambda. Okay, so when x is less equal to 8, the possibility is 0.8674, and then this area is 0.6321. So this area minus this will be 0.2326. And we can use Excel to calculate that. Okay, so Excel, we just do expand.disk. That's what we did before. And then use X lambda and then realize cumulative or not. And in this case, it's cumulative. Okay. Yeah. Any questions? I'll give you example so you can practice using example. So the easiest one is the uniform probability distribution. Okay, so basically it's the area. So this means this is A, this is B. So for X and for the X happen is as long as X is between A and B, it's the probability is this much. Okay. So so A and B, A is the lower bound, B is the upper bound. That's that. And then the possibility is this x1, x2 minus x2 divided by b minus a. So let me give you examples. I think it's easier to use examples. So here, based on a survey, to finish a task that's, you know, between, it will be between 50 and 100%, that it always finish in this possibility. What's the possibility that we finish it in 50 to, let's say, 100 days. Okay, so based on the previous example, we always finish this between 50 and 100 days. So what's the possibility that we finish this between 50 and 60 days? So it's very simple. It's just, so let me draw. I like to draw. So the uniform distribution is between 50 and 100. And we want to know what's the possibility between 50 and 60. So between 50 and 60, it will be this among the whole area. So it's basically just this area divided by this area. So it's 60 minus 50 divided by 100 minus 50. What if I ask you, so what about the possibility it's between 40 and 60? Still this, because there's nothing, there's no possibility there. Okay? Yeah. So it's 20% of chance. Any other questions? I'm going to, how many people? 1, 2, 3, 4, 5. I'm going to make copies and then I'll be back, okay? Give me a few minutes. break. And then notice that they changed the paper. So if you turn in this, that means you are here today, and you might get extra points. So one side is chapter 5 from last week, and one side is chapter 6. Okay. But we will discuss this next time. So put on your name. And then you can use Excel. You remember how to use, like, remember use Excel to get it? And the exit.
Both sides.
Huh? Oh, yeah, you can, I mean, one is quiz 5, one is quiz 6, one is quiz 7. Yeah. But quiz 6 is almost the same as quiz 5.
Okay.
Yeah. But you know to use Excel.
Oh, we already had a chapter 5 quiz.
Yeah, but I don't know why I have 2 quizzes for chapter. I don't remember. Maybe I thought, you know, we need to practice more. So when I print out my quiz 6, I realized it's chapter 5. So probably have 10 quizzes. So for those who are on Zoom, we can do it is a quiz up to quiz 7. Okay, because quiz 6 is chapter 5, quiz 5 is chapter 5, and quiz 7 is chapter 6. So next time we will go over chapter 4, 5, 6, 7.